Hello, my name is Michael Richardson. Today I'll be talking to you about concurrent rendering in your Vega application. Concurrent rendering was delivered as part of React 18 and is available today on React Native for Vega. If your app is running slow or you think it could run a lot faster, concurrent rendering is a great place to start. We see big improvements from both internal and third-party applications that have adopted it. We'll also talk about some of the things that you need to watch out for with concurrent rendering, as well as how to get started with it. Before we get into concurrent rendering itself, we're going to talk a little bit about how rendering in React Native works. React Native rendering has two phases in the render process. The first phase consists of the render function, and the render activity is what occurs when the JSX tree is initially created, as well as when the updates are made. And the example we have here on the screen is an example of when the JSX tree is initially created by the React components in your source code. And the first iteration of the render will execute all components to create the tree. During the render phase, upon an update, there could be a state change of any kind. This triggers a re-render to occur. The re-render occurs when the component where the update occurred and any child components. React creates a diff of the JSX tree to minimize the amount of overall changes, and that diff is called reconciliation. In the second phase, called commit, that's when we see the actual visual change to the application. This example is essentially showing a header tag being added to the page, which makes it visible to the user, and that is the end of the rendering process. So next, I want to talk about state change and side effects. So state is what manages the state of a component on the page. And in this example, when you click, you change the counter. When you click the button, it goes from 0 to 1 to 2, etc. Those are state updates. Whereas a side effect only runs once. And so if we were to talk about a real example where we wanted to load data from a server, we would only want the data to load once, which is what the example on the right is showing. Now I want to quickly talk about component purity. Component purity means that a function that's inside the render function itself has no side effects. The input directly defines the output. So for example, if you would have replaced the h1 hello name with like a new date function, even a relatively simple function, the component is no longer pure. That's because the date can change, and it actually does as time progresses, so it may have side effects, which means that it's not pure, which becomes relevant in concurrent rendering. So now let's quickly talk about the concept of concurrency in rendering. Like we said before, it was a feature that was introduced in React 18 and is available today on React Native for Vega. The key difference is the ability to interrupt and batch changes. In older versions of React, rendering was synchronous, which means that the moment the render kicked off, either from initial load or a state update, nothing could interrupt that render. Once the rendering occurs, you would see the change take effect on the screen, and then the next render could start. With React 18 and beyond, if you take advantage of concurrent rendering, you can now make rendering batchable and interruptible. Batching means that multiple renders can be batched in a single commit, and that's why purity matters, because batching is only done automatically on pure components. And then additionally, you can interrupt the render cycle, which we'll talk about why that's useful in a little bit, but it's particularly useful when you're doing something that's expensive from a processing perspective while you still want to maintain user interactivity in the application. Now let's talk about strict mode. In order to get started with concurrent rendering, we recommend that you wrap your application in strict mode, which this example on the screen shows. Strict mode is both a concept and a feature that helps you identify how and when components in your application do not follow the rules of React. When you enable strict mode, you can quickly identify undesired scenarios of rendering. Strict mode, upon mounting the component, will re-render it an extra time to find bugs due to impure rendering. It will also rerun side effects an extra time to find missing effect cleanup. It also has checks for things like deprecated APIs, which is also convenient and useful for making your application better. And then finally, as a quick reminder, strict mode only runs in development, which means that it helps you during the development cycle, but does not do anything in release mode. Now I'm going to talk you through a couple of examples. The first example that we're going to talk through is a scenario where you have a chat application with infinite scroll list, and we'll talk about how prioritization becomes useful. With concurrent rendering, you can prioritize the urgency of updates versus traditional rendering that you have a first in, first out, first come, first serve rendering. We ideally want to prioritize user input over the loading of things like historical messages because that can be loaded and rendered when the application isn't busy or the user isn't directly interacting. And you also want to prioritize the notification banner over loading historical messages, but probably not to interrupt typing. And so with concurrent rendering, you have the ability to create this prioritization. Whereas with traditional rendering, you would have had a noticeable input lag while the historical messages were loading, because until the historical messages were finished loading, you wouldn't be able to actually interact with it, in this case, the on-screen keyboard, so you would be able to type into it. Now let's look at it from a different angle. Let's talk about prioritization, but from a time graph instead of from what the application looks like. So you can see that we're prioritizing clicks and typing over loading and scrolling. So we can allow scrolling to continue to occur. We always prioritize clicking and typing. This enables input to remain responsive without noticeable input lag, as well as a notification banner can appear as needed. Now that we've gone through the example, I want to talk to you about the APIs that you need to take advantage of this. The first is use transition. It's a React hook that was released as part of React 18 that allows you to render part of the UI in the background. It's critical for making concurrent rendering performance, state, and UI transitions. It also enables UI interactivity while business logic and rendering components would otherwise make the application appear to be slow. The second API that I want you to look at is suspense. Suspense is a fallback mechanism that displays a placeholder while the children finish loading that particular component. It's common in TV applications that you may be loading images for like artwork for movies or TV shows that may be large and maybe a lot of them. And so suspense would allow you to put a placeholder there while the network calls are downloading the images. And the UI remains interactive during this period, and then suspense swaps out the real image for the placeholder once the content arrives. And then the last API that I want to point you toward is lazy. And lazy, as the name would imply, allows you to defer loading until the code components are rendered for the first time. So if you use lazy and suspense together with dynamic imports, that will again make your application appear to be faster, more responsive. The second example that I wanted to talk you through is a search results page, because they're again very common in TV applications and even in mobile applications. In our example, the user is typing something into the search bar at the top. There's a set of results displaying as they type. With traditional rendering, which is blocking by nature, when you type something, assuming that it's an immediate search result, it will cause the list to re-render before you can type the next thing. It's going to make the user frustrated. They'll feel like the application is laggy or janky. Whereas with concurrent rendering, because of interruptibility, you can prioritize the user input over everything else. So the search results can still be loading, but prioritized below the user input. Another example that I want to talk you through is what looks a lot like the homepage of the Fire TV, as well as the homepage of a lot of applications you would see on TVs, where there's some banner artwork at the top, some kind of hero logos, and then rows and columns of content. In this example, which again is really common in TV applications, you have vertical lists and horizontal lists, and in some cases, lists of lists. And you want scrolling speed to be fast across these. But the page is large, lots of items in the list, and lots of lists. It also requires animation so that the transitions feel smooth, which can be very difficult to do with traditional rendering because it will appear that there's a lag because it's trying to render the additional content. Whereas with concurrent rendering, we can schedule the rendering in chunks, which will allow high priority tasks such as the animation and the scrolling behavior with background tasks that will load additional data, more complicated animations, potentially artwork, etc. So this all sounds great, right? Well, how can I get started? The best way to get started, as we talked about before, go ahead and enable strict mode in your application. That would be the first place that we would recommend that you start. Strict mode allows you to quickly detect problems, and by wrapping your application in strict mode, it will trigger errors from unsafe life cycles and unexpected side effects. So, okay, now that you've implemented strict mode, there are a couple of things that it will help you find as well. The first example that I want to show you is an unsafe side effect update where you've not done proper cleanup. In the example on the left, bad component, no cleanup has been done, which could trigger multiple duplicate fetches in strict mode. Whereas the example, good component on the right, does proper cleanup. So now in the second example, we're looking at an example of a counter that you have in a component. And the problem with the left example or bad counter is that it's an unsafe update because there's a chance that it may run on an unmounted component if the component had been previously mounted and it started. Whereas the good counter example tracks to make sure that the component is still mounted and does explicit cleanup to ensure that the counter is not actually running when the component is unmounted. So if you're ready to get started on this, the quick recap of what you need to do is first, you always want to use cleanup functions and use effect. You want to avoid direct side effects and render functions, and you want to use React strict mode to detect issues early. Thank you so much for watching this presentation on concurrent rendering in Vega applications for React Native for Vega. If you have additional questions, feedback, comments, ideas, please feel free to reach out to us on DevTO, X, YouTube, or through our community forums that you can access through Amazon Developer Portal or developer.amazon.com. Thank you so much.